Alright, so we're going to talk about sight distances. And so sight distance in the vertical alignment part are for highways should provide ample sight distance for safe vehicle operating. So there's two types of sight distance that are involved, one for stopping and then one for passing. So stopping sight means it's the distance required given at a design speed. So in other words, if it's 60 feet, they want a sight distance of 570 feet. So this is AASHTO's chart. And AASHTO is your American Association of State Highway Transportation. So if you were going a design speed of 50 miles an hour, you would need 425 feet for stopping, and you would need 1,835 feet for passing. And so passing would be, if it's on a two-lane highway, it's for you to overtake a slower moving vehicle, pass it, and return to the proper lane of travel. So y'all have seen the solid lines and the dotted lines letting you know that you can actually cross the line and pass the vehicle and come back. So in the sections of highway that do not provide ample sight distance, then it needs to have the solid line knowing that you can't cross it. So that's where they'll either put signs up or they'll put the solid centerline marking to let you know that you do not have a ample passing distance. So you have to have certain criteria. And then if we're working with vertical curves, then we need to know, if we have some criteria that we can measure, can we figure out what the length of our vertical curve is? So this is working with sags, and this is working with a crest. So when we're working with the crest, and this is, like I said, you're either be stopping distance or could be passing distance, we're going to be using a couple of formulas. Now, the textbook didn't, they just gave us a formula, and most people that are like me are visual people, so they kind of want to know what this H1 and H2 are. So I'm going to show you really quick where that is. So I'm going to minimize. So this is Blackboard for Survey 2, and we're under still Module 2. I have a PDF that's marked sight distance. And I'm going to rotate it. So it's the exact same formula that this one's sight distance on a crest. Theirs is a little bit different, but the main thing I wanted you to look at is what H1 stood for. What does H1 stand for? And that's the height of the eye. Like if you're in a car, your height of your eye in relationship to an object in the road. So this is going to be H1, which is the height of the driver's eye. H2 will be the height of the object sighted in the roadway ahead. They're in feet. And then S is the stopping sight distance, which is we can take from a chart, and what we're solving for is the length of the curve. Now, there's two different equations that we'll be using, and we'll have to look. So we'll start with one equation and solve it, and then see if it meets the criteria, and if it doesn't, we'll move on and solve the second one. Alright, so just wanted to let you know kind of what this looked like before we got started. Alright, so I'm going to write a couple things down that I want you to know. So, again, you'll be given the stopping sight distance. That'll be given. What we're looking for is the length of the vertical curve in stations. Alright, so equation equation 25(9). So to use equation 25(9), S has to be less than L. So S is typically given in stations. So remember, that's 570 feet. So I'm going to be working the example for that, for one that's right here in the book underneath the 25(7). Alright, so here's a couple things. So S and L, looks like sand. S, I'm going to do an and sign. L are stations. Alright, so AASHTO has some recommendations. So they recommend, if we use H1 as 3.5 feet. So this is going to be a recommendation from them. H2 is going to be 2 feet. Now this is based off AASHTO. So these are going to be constants based off what AASHTO recommends the distances being. And they recommend H2 for stopping, and I'm going to write stopping. And H2 for passing, 4.25. Okay, so now we want to go ahead and start working a problem, putting some numbers in so you'll kind of see how they... So we want to first start with equation 25(9). So L equals S squared G1 minus G2 over 2 square root of H1 plus square root of H2, and that's squared. So typically it's a formula. So L equals, so in this problem it says that the curve has provided a 570 foot stopping sight distance. The G1 is 1 plus 4, and the G2 is a -1. So if I plug those numbers, so my S squared, remember this is in stations, so that'd be 5.7 squared. G1 is a 1.4, and it's going to be minus G2, and our G2 is a -1, so again, negative and negative makes a positive, and that's all over 2 times the square root of 3.5 and H2, this is a stopping, and we'll square that. So again, constants for stopping, the H1 is 3.5, the H2 is 2, we're going to square that. We'll take the square root of both and then square it, times it by 2, and then divide that into the top. So I'm just going to put the top in first. So I got a 5.7 squared, and that's my sight distance and station. And I'm going to multiply that up times the 1.4 plus my 1. So right now I've got L equals, on the top part right now I've got 77.976. So I did the 5.7 squared and then the 1.4 minus a minus 1, which is a positive 1. So I multiplied that by 2.4. And then I'm going to do the bottom. And then I get 21.583 when I do the bottom half. So I'm going to take 77.976 divide 21.583, and that gives me 3.61 stations. Okay, so right now L is 3.61 and the S was 5.7. So to use this, S has to be less than L, and it is not. So to use equation, (25.9), we have a S is 5.7 and L is 3.61. To use this equation, S has to be less than L. So this is going to be like, you want to do the 25.9 first, and then if it comes out that L is less than the S, that means you need to move on to equation 2. So equation 2 is a little different, and so this is equation 2. Since our S was greater, we need to go to equation 2 10. So I'm going to go ahead and scroll down. I'm just going to go ahead and get me some extra pages put in before I start writing, and I'll delete them. Alright, so the next equation, and again, this is a stopping distance. So it would be L equals 2S minus 2 square root of h1 plus square root of h2 squared, g1 minus g2. Right, so L equals 2 times, and they give us 5.7 minus 2 over square root of 3.5 plus square root of 2. This is squared over g1 1.4 minus g2, which is a 1. So of course that's going to be added. And when you plug that into your calculator, you're going to get 2.41 stations. So this formula works with S being greater than L. Since the S is S is 5.7. And L is 2.4. The length of the curve, L in stations, is 2.41. So I'm going to write stations. And L in feet would be 241 feet. So that's what we would set our vertical curve at, 241, to meet those requirements. Alright, so the second one in this is a solution for the sight distance. The next one is the sag curve. So that would be our sight distance. And if we were doing a passing distance, the only thing different you would use is, for the formulas, would be your H2. Your H2 would be 4.25. So just let you know, if you're trying to solve for a passing distance, you would just use the different H2, which is 4.25, and everything else would be usually given. Alright, so that's both of these are for a crest. And the next one, I'm going to scroll down, is for a sag. Alright, so a sag's, when it's coming down. A sag vertical curve also limits sight distance because they reduce lengths ahead that can be illuminated by headlights. So during the night driving, so there are equations that we're going to apply in computing the lengths of a sag curve based on headlight criteria. So right here gives you your headlight material, and again, and this one doesn't have H1s and H2s, it just has some constants in it. So so for that one, of course, you've got you would have to do the same thing. You would have to solve. S is your distance, or your required distance in stations, your G2 minus G1. The 4 plus the 3.5s. The 4 and that 3.5 are constants. And so again, they're constants here. So just remember, I'll write them here for you. So L equals. So for the first one, S is less than L. So you always want to do the first one, and if it comes out correct, you will just stop. If it doesn't, you'll move on to the second equations. So S squared equals G2 minus G1 over 4 plus 3.5 times S. S is stations. That's your length of your curve, or the stopping distance, sorry. Stopping distance in stations. The 4 and the 5 and 3.5 are constants. So, and then if we would actually solve for one and you got S, the S ended up being less than the L, you would stop. But if S happened to be greater than your L, then you would go on and use the second equation, which is 2512. Alright, so I want to work a problem in the back of the book because I gave you one, and I'm just going to work the one, I'm going to work 2530. And of course they gave us. So this one is, it wants a sight distance. This is the grade of a +1. So this is problem in the back of the book. 2530. That's page 776. So basically I've got a plus 3% and a negative 2%. So again, we're going to be looking for the L. So that means it's a crest. So it gave you S. So given S is 600 feet. So that would be your G1. That would be your G2. L would be 600, or S would be 600 feet, so that would be 6 stations. H1 is 3.5, and H2 is 2. So again, those are the ones that AASHTO recommends. So I'm going to start right here with this equation first. I'm going to go and scroll up. So L equals S squared G1 minus G2 all over 2 square root of H1 plus square root of H2 squared. L equals 6 squared G1 is 3, and it's minus G2, which is a negative 2, over 2 times square root of 3.5 plus square root of 2. And this would be squared. So I'm just plugging in 3.5's H1 that was given in the problem. They gave me they gave us G1, which is 3%. It gave us G2 a negative 2%. H1, they gave that to you even though I told you what they should be right here based on AASHTO. They went ahead and told you it's 3.5 and that H2 should be 2, which is right here. Alright, so they want to, this one's, you know, a crest of the curve, and it's going to be for stopping. Alright, so I'm going to go ahead and solve for the top and put that in. So if I say 6 squared times 3 plus 2, that gives me 180. And then I'm going to do the bottom. And the reason I'm kind of doing this out just to see if you have a problem with your calculations, that you can check, make sure you're. And I got 21.583. Alright, so 180 divided by 21.583 gives me L equals 8.3399 stations. So if I'm looking, L is 3.3398 stations. Our S is 6. So where 6 is less than L, and it is, we can stop right here. So we wouldn't have to go on any further. This was one of the problems that was in the back of the book. So you should be able to check your work. So if they ask for the answer in feet, you would want to put in L equals 833.99 feet. Alright, so that's the end of doing sight distances. And the problem you have is a crest, and it's going to be a sight distance as well. Actually, it's going to be one for stopping because they tell you the H2 is 2.5, but you'd use the same formula. You just, instead of using the H2 of 2, it tells you to use 4.25. So I think everybody will do really good on that one. Not a big deal. Alright, I'll upload these to Blackboard and have them ready for you for next class. But you can go ahead and be looking at them, getting your homework done.